Hello everyone, my name is Jamie Guo and this is my video lab report for Physics 2211, Lab 3, Black Hole. To start off, I'll begin with the introduction by giving a brief background of the lab and describing its purpose. Then I'll talk about some key ideas and relevant formulas. Afterwards, I'll talk about the two coding models and the results for the two parts of the experiment and finish off with the discussion. The purpose of the first part of the lab was to observe motion of a star orbiting a black hole and calculate FNet components and finding the mass of the black hole. For part two, we use that mass to find a spaceship's initial velocity in order to not hit a planet. Some assumptions we made is the only forces acting on the star and the black hole is the gravitational force. The system is a star, surroundings is the black hole. Our results showed that the mass of the black hole was 8.14 e to 23 kilograms, and the spaceship's initial velocity is negative 6.26 e6, 7.5 e6, 0 meters per second. Some key ideas: we had to use the Newton's second law, which is the momentum principle. FNet can be split into two parts, which is FNet parallel and FNet perpendicular. FNet parallel is equal to dp over dt parallel, this is the force that causes a change in the momentum, and then F net perp, which is dp over dt perp. This is the force that causes a turning motion. Then gravitational force is shown above, and the magnitude of gravity is the gravitational constant times the two masses divided by r squared. For the initial data of the black hole, the gravitational constant is set to 6.7 e to negative 6. Star mass was equal to 2.0 e30. And then delta t, we were given 24 hours. We had to convert it to seconds. For the calculation part, we had to apply Newton's second law by finding the two different FNet components. This is done by first finding the change in momentum and dividing it by delta t to find FNet, which is equal to dp dt. Then using that, we could split it into two parts as the perpendicular part and the parallel. And then to find the mass of the black hole, we have to manipulate the gravitation force. And then we get mass is equal to force times r squared divided by gm, as shown on the left. And then our results showed, so for the mass of 8.14 e30 kilograms, found that by taking all the output masses and plugging them into an Excel spreadsheet and then finding the averages, and then the different FNet components can be seen above. For part two of the experiment, the initial condition, the mass of the black hole was carried over for part one, and everything else was held constant. For the calculations, we basically had to find the two components of gravity, one of the black hole acting on the spaceship and one of the planet acting on the spaceship, as seen on the left. And then on the right, we had to apply the velocity update and momentum and then position update formulas to find velocity and position. And since force of gravity is non-constant, the position update formula is going to use the velocity final from the velocity update formula. And then the results that we got for this was the initial velocity is negative 6.26 e6, 7.5 e6, 0 meters per second. The closest distance between the spaceship and the black hole was found to be 1.43939 e10 meters per meters. And then for possible sources of error, for part one, I could have let the code run a little longer to obtain more mass data to find a more accurate average. And then for part two, the initial velocity was a plug and choke kind of answer, so that definitely could have been a little off from the expected answer. And then I could have let the code run a little longer to obtain more data. So then for the what does it mean question, the FNet force and its parallel and perpendicular components are the same as the rate of change of momentum and its parallel and perpendicular components. This is shown before as FNet parallel is just equal to dp over dt parallel, which can be derived from Newton's second law. And then for the what if question, we basically had to find an initial velocity for our spaceship for it to orbit the black hole instead of just going off into space. And I found that velocity to be around negative 5.26 e6, 5.6 E60 meters per second. Thank you.